Make Hands-on Intro to Engineering Design, a course taught at the University of South Florida. Due to the creative nature of this course, exams are replaced by deliverables. This video shows a few examples of Deliverable 1, where students submit a video featuring their projects as an Autodesk Inventor simulation. The featured videos are Fighting Robots by Matt Olson, the Animatronic Hand by David Bartholomew, the T-Rex Timer by Laura Schlittler, the Skittle Turret by Sean Murphy, and the BMO by Francisco Giammattei. Enjoy!
Hello, my name is Matt Olson, and this is my video for the first deliverable of the Make project. My project, I'm calling the Fighting Robot project, emulates Rock'em Sock'em Robots, where two player-controlled robot boxers try to punch each other in the face. This is the block diagram for the player-controlled inputs. Right now I have both robots punching each other together, and either fist moving with its opponent's fist. As you can see, the fists do connect with the opponent's face, which will have a small sensor here.
My name is David Bartholomew, and today I will discuss my design of an animatronic hand. I will go through the control system block diagram for my hand, as well as a short simulation of some of the functionalities of the hand. This is my control system block diagram. The primary components I will be using are the IR remote, the IR receiver, and 5 servos. Here is the simulation showing how each finger will move. All fingers will close and then they will open. This is just a simple test to see how it will move. The remote will have many different functions programmed into it.
Hello, my name is Laura Schlittler, and this video will describe the design of a very scary Tyrannosaurus Rex egg timer. The concept behind the clock is to provide an accurate timepiece that has egg timer functionality to be operated by a remote control and interact with the user on the LCD display. Once made, I will draw a T-Rex on the 3D printed clock face so that it appears that the 3D printed minute and hour hands are two of his arms and legs. The functionality of the clock will be accomplished using a control system as diagrammed here. There is a small clock motor that will control the movement of the analog clock hands. The remote control will be used to turn the timer and buzzer on and off, as well as advance, reduce, start, stop, and clear the timer functions. This rendered image shows the internal structure of the clock. Here we have the Arduino Uno microcontroller, a mini breadboard for all the electrical components, the clock motor with the arm that can separately control the minute and the hour hands for accurate time. Here we have a close-up of all the components which will be inserted into the back of the casing. This is the LCD display, the ultrasonic sensor, and the infrared sensor, as well as the motor, whose arm will go through the top of the casing, through the clock face to control the minute and hour hands.
Sean Murphy, Make Course, Deliverable 1. The idea of this project is a mouth-seeking Skittle turret gun. Central to the project is a Raspberry Pi running vision processing from a Raspberry Pi camera that communicates the location and relative size of a human mouth to an Arduino. The Arduino will then control two different servos to pan and tilt the Skittle turret, a third servo to actually actuate the Skittle turret to fire and release the stored up energy. The pan mechanism of the gun has a servo near the base. The servo horn is embedded in the orange piece of plastic. For tilt, similar mechanism. To cock the gun, the stepper motor will drive the gear and the piston stores up spring energy. When the piston is fully cocked back, a Skittle will fall down from the hopper to fire the gun. The servo motor will go ahead and move a small cam mechanism which allows the piston to be pulled up from the spring tension and then fly forward, expelling the Skittle, hopefully into someone's mouth.
Hi, my name is Francisco Giammattei. I am an electrical engineering student currently attending USF. Here is the control system block diagram for the project BMO. The Arduino board itself cannot decode MP3 file formats. In order to remove this limitation, I will use the SparkFun MP3 shield. This shield properly decodes MP3 files and has a microSD for storage. Now for the fun part. The first function is playing a song, which is activated when pressing the cross button. Opening the screen, revealing a drawer compartment with the proper size to store Nintendo 3DS cartridges can be activated using the red button. This will also trigger a soundbite of BMO's famous quotes, "Who wants to play video games?" And finally, the BMO chop function will be performed along with its appropriate soundbite.
We hope you enjoyed watching some examples of our Make course deliverable videos. Thanks for watching.